750. 500 must be
less than 500.
switch the microseconds. A lot less than 5 microseconds. It will be a lot. So I think.
We started off by creating a table which saves a heart rate associated with a timestamp. We also created an API with two endpoints, the first of which is read. This pulls all of the values from this table. The other is insert, and that one allows us to push something into the database. For example, a heart rate of 70, which should now be registered in here. And this would be used by the embedded device to push a heart rate into the table. We've been able to connect the ESP to a Wi-Fi network, and we've also been able to send a singular heart rate value to the insert endpoint. We can test this out right now. If we restart the ESP32, it should send a message as soon as it gets connected, as we can see here. And if you now check on the read.php, we can see that it successfully was added to the database.
So instead of writing a native Android app, we opted to use a React Native application in order to be able to write one code and then run it on Android, iOS, and also on a web app. We thought this could be very interesting and also very beneficial for a standard running app. Of course, the main difference is that this isn't written in Java in Android Studio, but written in JavaScript. Here I used Visual Studio for this. Now I'll show you the app using React Native and run it on an emulator that I have installed on my computer. So here we have our React Native app, we have our login screen where we can go to the main menu and switch between our current event tab and our history tab.
For peak detection, we set a digital threshold in our code, and then we calculate the BPM by dividing 60 by the time difference between the two detected peaks. If we now set the frequency to 2 Hz, we see that the BPM value becomes 120. We use the free RTOS tasks and queues to send the BPM values from the writer task to the reader task. In the next step, these values will be sent to the database using Wi-Fi.
Compared to Sprint 1, our React Native app has grown exponentially and has many features added. As you can see, our app now has a custom icon. Our main menu screen is still quite similar, but the buttons now actually lead to their respective pages. Our sign up button leads to our sign up page, and our login button leads to our login page. I will now quickly log in to show the other functionalities of our app. As you can see, our password also changes its characters to dots after being typed to further improve the security of our app. After we log in, we are greeted by our main menu screen where we can show the running tip of the day. As you can see, the user can switch between tips. They can go to the next tip and the previous tip, constantly changing the title, the body of text, and the image underneath it. In order to switch between tabs, we use a bottom navigation tool from React Native Paper. As you can see here at the bottom, you can switch to the different tab, of course then showing only the name of the current tab, also changing the color of the bottom navigation. We are now in our current event tab. Here you can get an overview of different values such as your average heart rate or your current zone. You can also get a graph at the bottom which shows a graphical interface of all the collected data from the ESP. We can also increase and decrease your desired zone. Our program will also compare the desired zone to the current zone and check if you are in your desired zone or not. Should you leave your desired zone by running slower or running faster, the app actually warns you about this and will give you a notification. Also, if you try to increase your or decrease your zone too much, you will also be greeted by an error message, as this would not make sense in the context. For our last screen, we have our history of activities tab, where we can switch between different activities and get a more detailed overview of them. At the very bottom, we have also made an attempt to connect near the database. This is actually receiving data from our database, just in order to be able to check if our app would actually be able to connect, and it has.
So when you start the device, it gets the last session ID from the database, or the API that we wrote. Then, once we start a session by pressing a button, it's going to try to increment this value and wait for confirmation from the server. After it does this, it starts sending values to the server with our heart rate, the moving average from the previous few sprints, associated with the new session ID. Once this happens, like every time we send a request to the server, the session is also synchronized with the server. So let me press the button right now, and we can see that 3 values were sent. Let me stop the session. When the session is stopped, we see that it also sends a timestamp end. This way, the mobile app, for example, knows how long the session took. But we see that the session ID is synchronized. We created a small dashboard for both the users and the developers, us, to see whether or not our code is robust and to see if we have any errors or not. The first section we have are the Apache error logs. Next up, we make a lot of different modifications to our code, and depending on the modification, it can change the way the API works. We have DAO tests, so this tests the classes directly and sees if their output is good or not. And we also have endpoint tests, but these are going to be added later. I can refresh the page with tests, and then we'll see that the tests were all successful. We also get a lot of data. Finally, we also have the endpoint logs.
They tell you that everyone's got a job for control systems. They asked me to be an assistant.
Our React Native app has seen many new improvements. We have opted to completely redesign the UI, giving it a more modern and clean look. Our new homepage now gives a quick overview of the stats using data from our database. We have moved the tip of the day to its own separate screen, and we have added a functionality to show whether or not we have been able to connect to the database. Clicking on the status icon will give the user a clean overview from the previous connection logs. This will help both the user and the developer improve the setup. Our current session now perfectly functions as required. It will update its values at regular intervals and will only add newly added data instead of reading all the available data and completely overriding the current data array. This is achieved by dynamically working with an offset in the jQuery URL, and helps us decrease the load and improve the performance of our app. Our history tab now loads all the previous sessions from the database, giving a detailed overview of the 5 most recent ones. When pressing the button at the bottom, the user will be given a complete overview of all the previous sessions, although this is less detailed.